Hi everyone, we're starting our new lesson on systems of inequalities. We're going to continue with that, and what we're going to do is we're going to graph a system of inequalities that describes a region of a coordinate plane, and we're going to find a system of linear inequalities that defines a given graph so that you can represent and interpret situations that involve inequalities. Okay, so I'm going to skip through the two opening problems that we will do in class, and we're going to go straight into some more examples that we had done in the previous video lesson. So the first question you're being asked here is to find an inequality that defines the shaded region. Now, in order to do that, we need to first find out what the equation of this red line is. So the way we're going to do that is we're going to do that by recalling our equation for a linear equation, which is y equals mx plus b. And the first thing I'm going to notice is that the value of the b, which I know to be the y-intercept, if I take a look at it on my graph, it's actually given to me as being 3. So I know that the y-intercept, or b, equals 3, and I need to find now my slope, or my gradient. So because I am given 2 points, I am able to find the slope. So I'm going to find my slope by saying the change in the values of the y over the change in the values of the x, or the rise over the run, will tell me that I'm going to do 3 minus 0 over 0 minus 6. And I get negative 3 over 6, which equals negative 1/2. So I now know I have enough information to figure out what the equation of the line is. I know my slope is equal to negative 1/2, and it's going to be multiplied by x, and it's plus our value of the b, or the y-intercept, which is equal to 3 in this case. Now, because the shaded area of our graph seems to be below the actual line, then I'm going to say that y has to be less than negative 1/2 x plus 3. But the next thing I need to look at is to see whether the actual line that's given, whether it is a solid line or a dotted line. Because it is a solid line, then that means that I am including those values of that line. If the line had been dotted, then I would have just said y was less than negative 1/2 plus 3. But since it is a solid line, then it's going to be y is less than or equal to negative 1/2 x plus 3. Now, if I take a look at a second example, so the second example is asking me to graph 2 bracket x plus y is greater than x plus y. Well, the best thing that I can be doing at this point is I need to expand. So I will say that I have 2x plus 2y is greater than x plus y. And since we are isolating for y, because we always write our equations or inequalities in terms of y equaling, okay, so everything is written in terms of x, then I can say that 2y minus y has to be greater than negative 2x plus x, so that I get y equaling, or not equaling, being greater than, y is greater than negative x. Now, what does that tell me? Y being greater than negative x means that negative x is going to be going in this direction, so it's 0, 0, 1 and negative 1, 2 and negative 2, 3 and negative 3, and so on the other side we will have negative 1 and 1, negative 2 and 2, negative 3 and 3. And I think that would be sufficient in order to make our line here. Now, we take a look again at our inequality symbol here. Our inequality symbol is greater than. It does not say greater than and equal to. Therefore, I automatically will change my solid line into a dotted line, so that I will have a dotted line here. So I'm just going to quickly make a dotted line, and I'm going to change the color on it so we can see it better, and change the dot so it's a little bit easier, so that I have my dotted line going through these points. Okay. Now, because the problem again says that y has to be greater than negative x, then that means that it's safe to assume that everything above the line is going to be included. So that means that this whole area above the graph is going to be the area that is going to satisfy our inequality. So satisfying the inequality simply means that the values that will make the statement above true have to be values above that line. So for example, if I chose 0 and 2, then that I just chose a random point. I chose a test point. If I were to replace x and y with 0 and 2 consecutively, then that means that I should be getting my left-hand side being greater than my right-hand side. So I'm just going to try using the test point just to show you. It's not something that you have to do, but it's just to make my point, to show you that we are showing that there are numerous values of x that will make this statement true, that 2 bracket x plus y is greater than x plus y. So I will say 2 times 0 plus 2 is greater than 0 plus 2. And I end up getting 4 is greater than 2. And that is a true statement. So I know that the values that are above that line are the ones that make that statement above true. All right, if we look at the next one, now you were being asked to graph this system of inequalities. So you're graphing 2 lines, you're graphing 2 inequalities. So I'm going to quickly make my my graph, and I will make it in black, so that I have a line. Here's my graph, 1 and 2 lines. We are to always remember to label our x and y axes, and we are always going to place our scale, whether it's 1 to 1 or 1 by 2 or 2 by 1. It's up to you to decide how you want to make it, just as long as it is clear to me what it is exactly, what scale it is that you used. Okay, so let's take a look at the very first graph. The very first graph, I'm going to color that in red, so I'll just put a little red dot next to it. And the next graph I will color in blue. Alright, so my first graph is y has to be less than or equal to x plus 5. So I know automatically that my y-intercept in the y equals mx plus b, I know that my y-intercept is going to be at 0, 5. So it's 1, 2, 3, 4, 5. So there's my first point of contact. Now, I know my slope has to be, because its y is less than x plus 5, since the x stands for the m, or the slope in front of the x, is 1 over 1x, so it's rise over run, it means that I am moving up 1 and 1 to the right, up 1 and 1 to the right, up 1 and 1 to the right. So that as I am graphing this, I can very easily say that is my line right there. And I can write down y is less than or equal to x plus 5. When I have to draw out now x is less than 6, now x being less than 6, notice that it doesn't have a y on it. There is no y because we have a vertical line. Every value of x is equal to 6. The only values that are changing are the y values, but my value of the x remains a constant. So that I will go to 1, 2, 3, 4, 5, 6. There's my value of 6. And I'm going to make it a line that is dotted because it is less than, it's not less than and equal to. So there is my dotted line over there. Okay? And I will call that x is less than 6. Okay, now, because the values have to be, because our values have to be less than or equal to x plus 5. So I'm going to color that in orange. So since that has to be in orange, that is x is less than or equal to x plus 5. Okay, it's all of this. Okay, and going on for that matter. Okay. Now I'm going to do the value of x being less than 6. So if x is less than 6 means that I'm going to be looking at everything that is to the left of my graph. Okay, now the area that is being covered by both of the orange and the yellow, the orange and the pink, okay, that is going to be the area that I am looking for, that they have in common, so that my line can continue like this, so that I have all of this, as I'm coloring it in, okay, all of this area under here, all of it, okay, because it continues also with the orange, right down here. So the area that seems to have the overlapping of the orange and the pink is the system of inequalities. Those are the values that would make both of these inequalities true. So if I really wanted to, I could change it to a third color, but I'm afraid that I'm going to just screw it up a little bit. So the area that would then be included to make the statement true would be all the area inside this triangle here, which really is going on forever under here, but it's this entire blue area. And so if I were to pick a number, and I think I'm going to pick a number, if I pick a number, and I'll do two of them, I'll pick two test points, one that works, so I'll pick a test point that works, and then I'll pick a test point that doesn't work. Okay? So I'll pick a test point that works. Well, I'm going to cheat, and I'm just going to take 0, 0, because 0, 0 sits right in there. So that I'll say, taking the test point 0, 0, then I will say 0 has to be less than or equal to 0 plus 5. And 0 is less than or equal to 5. That makes it true, in that my left-hand side does equal my right-hand side. So the test point does work here. Okay? Now I'm going to do an example of a test point that doesn't work. And a test point that doesn't work, let's see if we can just take a look at it on the graph. How about if I pick a point such as -1 and 1, 2, 3, 4, 5, 6, 7. So there's an area, -1 and 7. -1 and 7 does not fall into the area where both graphs overlap. So if I pick the test point, so I'm just writing test point that's not working. I picked -1 and 7, so I will say that 7 has to be less than or equal to -1 plus 5. Is 7 less than or equal to 4? No, it is not. It is false. So that we know that the left-hand side does not equal the right-hand side. Now let me just reiterate that this is not something that you are obligated to do. I am just showing you that the points that will work and will make the statements above true, the two statements or the two inequalities true, have to be points that are found where there's the overlapping. And where there is no overlapping, those are the points where it's not going to work. So I took a point that was in the area where it works, and I chose a point outside where it doesn't work. And as you can see, the one that didn't work was outside of the area that was overlapping. Okay. The next one, we need to find the system of inequalities here by defining each shaded region. So what we're going to do is we're going to quickly pick two points from each line, and we'll get the equations of the lines. So my equation of the line, for the first one, I've got -3 and 3, and I also have 0 and 0. So I know that my y-intercept here my y-intercept is equal to 0, and I know that my slope, or my m, is going to equal 0 minus 3 over 0 minus negative 3, which just gives me negative 3 over 3, which equals negative 1. So I know, therefore, that y is equal to negative 1x. So I know my slope is mx plus b. So it's going to be negative 1x plus 0, which tells me that y is equal to negative x. Now, I used the equal sign through it. But because I am looking below where the common point is for both of them, because I'm looking below, then I can say that my first graph, which is the blue graph, okay, let me just point that out, the blue graph, that means that my blue graph is going to be y has to be less than or equal to negative x. It's equal to it because we have a solid line. Now, if I look at the second graph very quickly, I can see that on the second graph, my y-intercept is equal to negative 5, and I can find my slope very quickly by saying that 0 minus negative 5 over 4 minus 0 is equal to 5 over 4. So I know that the slope equals 5 over 4. Now that I have the slope equaling 5 over 4, I can now write y. Now, because again, it's going below and it's going to be a line, a solid line, y is going to be less than or equal to 5/4 x, and then it's going to be minus 5.